Hi everyone, I'm Lion, an engineer passionate about aerodynamics and hydrodynamics. If you enjoy my small-scale engineering projects, don't hesitate to follow me and stay tuned. After selecting the electric motor and the corresponding battery, I conducted a basic aerodynamic analysis and optimization of the main components of the aircraft. This part is divided into two sections: the selection of the basic configuration and wing design, and the calculation and optimization of aircraft stability. In this video, I will share the basic layout and wing configuration selection. In order to perform a basic aerodynamic analysis and optimization using XFLR5, I chose the Velis Electro by Pipistrel, a similar electric aircraft, as a reference for the overall shape. Based on that, I created a simplified symmetric model. At the same time, I incorporated estimated weights for each component to calculate the basic lift and drag coefficients of the model. Comparing the results with and without the fuselage, first we can observe that the CMCL curve has a negative slope, indicating static stability. Based on the calculation results, we can see that as lift increases, the pitching moment becomes more nose down, which helps the aircraft return to a stable condition. Similarly, when the lift decreases, the pitching moment becomes nose up, increasing the angle of attack and helping to restore lift. This behavior indicates that the aircraft is in a statically stable state. From the CLO alpha graph, we can see that the aircraft's stable point is approximately at a lift coefficient, CL, of 1, which corresponds to an angle of attack of around 5 degrees. This means that the preliminary model tends to maintain stable, trimmed flight at an angle of attack of 5 degrees. After verifying that the preliminary model performs without major issues, the next step is the selection of a suitable wing configuration. Several common configurations used in light aircraft are chosen for initial comparison, followed by further screening. Once all models are imported into the analysis software, attention is focused on key parameters such as the lift coefficient, lift-to-drag ratio, pitching moment coefficient, and stall behavior. A low Reynolds number is set here, assuming still air. The critical Reynolds number is taken as 3, and the transition points of the boundary layer on both the upper and lower surfaces are ignored. In addition, based on the approximate speed range of the Velis Electro Pipistrel, the boundary values of the Reynolds number are calculated to analyze the wing configurations under both lower and upper bounds. NACA 2312 and GAW1 show the best efficiency, CLCD, ideal for longer flight. GAW1 has a good stall margin but lower CL, while E197 and NACA 23012 generate more lift. For stability, CM, NACA 23012 stays steady at moderate angles, E197 varies more at high angles. After selecting the two airfoils, NACA 23012 blue line and E197 red line, we compare the CP diagrams at different angles of attack to make the final choice. The analysis of the KL alpha plot shows that the stall angle of the NACA 23012 is around 20 degrees, while in this case it reaches 19 degrees. Similarly, the stall angle of the E197 airfoil can be specified as 23 degrees. It is observed that flow separation on the NACA 23012 occurs at an angle of attack of 10 degrees, while for the E197 it occurs at around 6 degrees. Finally, we compared the aerodynamic center and the self-stability of the two airfoils. Both have a neutral point, NP, at C4, and essentially the same self-stability. In comparison, the NACA 23012 also shows better longitudinal stability. Although its stall speed is slightly lower, this can be compensated by wing configuration and the addition of a leading-edge slat. Therefore, NRK 23012 is chosen as the next wing type. Finally, the NACA 23012 airfoil is selected as the main wing configuration as it best suits the requirements of this small electric aircraft. The next step is to analyze and adjust the aircraft's stability based on the preliminary layout. Thank you again for watching. If you're interested in the Lavion Ideal channel or would like to follow the wise guidance from Lion, don't hesitate. Subscribe to the channel.